One of the things that any heat and air conditioning company will do is clean an evaporator coil. And the importance of this is to keep buildup off the coil, to keep the airflow coming through this coil as well as possible. Also, what you don't see is the dirt being accumulated. There's also a film that's developed over the aluminum surfaces. Kind of acts as an insulation, so it's always good to have that coil cleaned, improve airflow, improve the heat transfer of the air coming through. It's very vital. And there's some other things we're going to do as we go through to improve the airflow and make sure the system is running as well as we can make it run. This is one of the most important, but yet most overlooked problems with airflow when we're doing a tune-up. We come in and see a blower wheel which has a lot of buildup. The problem with the buildup is it can decrease your airflow upwards to from anywhere from 25 to 50%. And you can see this one's pretty built up. So we're going to clean this off, and I'll probably save some of the cleanings so you can just get an idea of exactly how much debris is collected onto this wheel. Now, where this comes from is bad air coming through the system, which can be better filtered. There could be duct leakage, bringing in unfiltered air through the system. And the other issue with that is once it's in to this point where it's collecting on the blades, it's also in your air that's in your house. So some better filtration can keep this to it down, but these still need to be periodically removed and cleaned, just to ensure that they're working as efficiently as they can. Okay, now that we have the wheel removed from the housing and the motors removed from the wheel, I just want to take another look at this and see what we're gonna be up against cleaning this wheel off. We're also going to clean out the housing. It's got a lot of considerable amount of built up. This may not be affecting the airflow a lot, however, I still want to get it out of there, get it out of my airflow, keep it from coming back and attaching itself to the wheel itself, and just clean that up. So what I want to do is scrape off some of this that's collected on the wheel so we can get a better idea of exactly how much that is, and an idea how much it's going to affect what the airflow process of this system. Okay, so this is a little bit of what I scraped off. We were maybe 6 or 7 fins on that blower, you know, and as you can see, we've got a pretty sizable amount of debris from there, you know, and even here you can see just how many, and that's just half of that half of the wheel. There's a completely different half on this side, obviously. But what we're going to do is use a chemical cleaner and a water hose and get that cleaned up thoroughly. But I can just imagine if that's only 5 fins with this pile of debris here, there's quite a bit of buildup on that. Okay, so now with the complete cleaning of this blower wheel, as you can see, my buildup is gone. I've actually accomplished more than just improving the airflow. This is going to reduce the stress on the motor that drives this wheel. It's also going to help keep this in balance, because as you can see right here, this is a little weight like they would put on a tire, just to keep everything in balance. Of course, that is done at the factory when they process the wheel as far as getting it balanced, and there's probably one or two more here. There's another one there. Now that we got those, we're going to keep those in place. We've got the excess dirt off, so hopefully we've just increased the life of the motor that drives this, and also increased the efficiency of the system altogether. Now, as I complete the reassembly of the blower assembly after the cleaning, almost every motor in your air conditioning system is going to have a capacitor. This is to overcome starting torque and to reduce the amp draw as the motor is running. As these weaken or even fail, the motor stops working or works intermittently, overheats. They're all thermally protected in case something like this occurs. But you see there, it's a 7.5 microfarad at plus or minus 10%. Temperature plays a role. It's a pretty cool morning, so we're going to put a test on this and make sure we're at the right capacitance. If not, we're going to recommend replacement if we're not in that range of tolerance. Okay, that's a good thing we ended up checking this capacitor before we reassemble this motor and install it. We're going to put, remember this was a 7.5 rated plus or minus 10%. Got what they call a capacitor tester here. Oh, I'm going to have a little trouble plugging it into my capacitor, it looks like. If I didn't have to hold the camera, this would be easier. Might be easier just to do this. Let's push straight down here. There we go. Alright, so we're at 3.64. I mean, we're very close to 50% below tolerance on the capacitor. Like I said, low capacitance reading is going to increase the amp draw on the motor, virtually making this motor work harder and get hotter than what it would normally operate at. So replacing this again, hopefully expand the life of my motor, and you know, this is a good recommendation for preventive maintenance. You know, everything we can do to protect this motor just by changing a capacitor and cleaning the wheel. Obviously this is the most expensive part of the operation here. Okay, my final check before we reinstall the motor. Of course, besides putting the new capacitor on, I'm going to make sure now that we're fully assembled I don't have any scrubs in this blower wheel, that it's not striking anything. I also want to make sure, some motors have oil ports where they request that they be oiled periodically, once a year, a few drops. You know, as we look around this motor, around the edges, no oil ports. A lot of the more modern motors do not require that you oil the motor. So, you know, had this oil ports on it, we would have went ahead and oiled the motor while we had it out, and made sure it was properly lubricated. Okay, so we're ready to speak to the homeowner about installing a new capacitor here and reinserting this back into our system.